Alright, so today we are looking at what's known as an Argand diagram. So an Argand diagram, as it says there, it's a geometric or graphical representation of a complex number. And so it's a modified version of the Cartesian plane. So on here's example here. So the horizontal axis has the real component, and the vertical axis, the imaginary component. So as it says, it shows you here, this particular point there on the graph. So, you know, Cartesian form, that point there would have the coordinates of 3 and 1. Now, because this is an Argand diagram, what it represents is this 3 plus I, so real component of 3, imaginary component of 1, so that's a 3 plus I. Alright, so because of the relationship to the Cartesian plane, when we write this particular form, A plus BI, so here 3 plus I, that's called the Cartesian form. There is another form that we'll look at a little bit later, but Cartesian form is this here, and bang, it goes straight onto the Argand diagram. Okay, so let's have a look. Represent the following on an Argand diagram. So the first one for A is just the real number 2. So we've got it's 2 plus 0i, yeah? So 2 plus 0i is that point right there. Alright, then the next point we're asked to put on here is negative 3i, so that's like 0 minus 3i, which is down there. Alright, then the next one is interesting. Let's go there. So we've got negative of 2 plus 3i. So if you like to expand that bracket, it's negative 2 minus 3i. So negative 2 in the real direction and negative 3 in the imaginary direction brings us down to here. Oh, I forgot this one in the middle. Forgot that one. Let's go back and do that one. Put that one in yellow. That's this one here. 2 in the real direction, negative 1 in the imaginary direction. There it is right there. And then the last one here. Let's go purple. Negative 1 plus 2i, and there it is there. Alright, so it's simply how we do it. So just remember, it's got labelled here, the real part is in the horizontal axis and the vertical axis is the imaginary part. Alright, so let's have a look at another example, which down here says let Z1 equal 1 minus 4i and Z2 equal negative 2 plus 2i. Find Z1 plus Z2 and illustrate. Alright, so Z1 plus Z2 is 1 minus 4i plus negative 2 plus 2i, adding our real components, minus 1, adding our imaginary components, minus 2i, I believe. Alright, so negative 1 minus 2i. So negative 1 minus 2i is there. So that's Z1 plus Z2. Now, I'll just point something out. If we go back to the origin, our Z1 and Z2, I'm just going to put them on. So 1 minus 4i. So I just want to point something out at the moment. So Z1 is 1 minus 4i. So 1 minus 4i, 1 minus 4i is there. Alright, so that's Z1. And that distance down there. Z2 is, let's go, that one, minus 2 plus 2i. So minus 2 plus 2i, which brings us to there. So Z2 would be there. Now, if you look at those dotted lines I've done, if I was to take this one here, this red one here, to there, and move it so that the point that connects with the origin connects here, you see it goes 2 that way and 2 this way. So if it connects here, 2 that way and 2 this way, so that distance that's in here is the same as this one there. Alright, so that and that distance, they're the same things. Alright, it's just the starting point is different. So when we, you're not going to, you might do a little bit later on in the year, but next year we'll do more with that. Alright, so that's about it for the Argand diagrams. So there are some more types of graphing that we can do with complex numbers, but for the moment, that's where we're going to leave it. So, as always, have fun.